Humanoids are having a moment right now. What's happening in humanoids that's so special right now that's different than what it's been in the past?
Once again, it's taken 20 odd years for humanoids to become an overnight success. But we really needed a certain critical tipping point. And those of us that have been enthusiastically following, we've watched them get commercial trials. And in the case of a couple of them, go from commercial trials to actual commercial contracts. And now that is a significant step. The primary reason for creating a humanoid robot is that it can use human tools. It can operate in human spaces designed for humans, operate equipment designed for humans, and it's also much easier for humans to train them, whether it's through remote teleoperation, having that direct kinematic mapping to the shape. So this translation, if my hands do this, then that robot's hands do this. If I reach up, it reaches up. And it's really a parallel mapping. I predict that there will be 1 million humanoid robots in commercial operation by 2030. There've been a whole sea of things, Moore's law in terms of computing technology, the same thing having an impact on sensing technology, the same thing happening in terms of just us knowing how to build robots better, so that we can now build a smaller, far better robot, and the role that AI and simulation have played. And so what I see now is it's been exponential growth meeting exponential growth.
Right. And
that caused this incredible speed up in competencies. So as robotics has met generative AI or large scale learning and large scale, not just language models, but multimodal models. And it's very much important for robotics. And that has met simulation. So what we're seeing now, and this goes back to, say, Google Arm Farm in the 2014 period, where a whole room full of robot arms working individually on the same tasks would come up with a whole lot more scenarios than one robot arm. But then those same strategies would be tested in simulation and through AI. And that would multiply the range of options and the ability to find the most successful pathways out of them, which would then be fed back into the real action of the robot arms the next day. So you had this to and fro happening between what the robots were exploring during the day, informing what they were learning and training during the night. And going back into the real world during the day. So you started this incredible flywheel of feedback loops. And we've just multiplied, in a sense, the number of feedback loops and the transitions from simulation to real world, back to simulation, to the real robotics deployments, back to simulation, and so on. So it's compounding. We're seeing incredible exponential growth compound. I like to consider myself a techno-pragmatist, not a techno-optimist or a techno-pessimist, but I believe that we're going to be moving forward, technologically speaking. It's almost an imperative, but that doesn't mean that we should do it thoughtlessly. I want to be one of the people that's moving forward, helping to put a brake on when it's needed in the right spots. And I want to share that information and that ability to see where the potential problems are. So my 5 laws for robotics start by sounding like Asimov, because I say robots should not kill. The thing is, this is one of our most fundamental laws, rules, moral principles across society. So we actually have frameworks to help us monitor that or control that. We have laws. If a robot is going to be acting lawfully, then it would not kill people. Physical safety, though, is just the starting point. See, the next thing from that is robots should be designed to be law-abiding.